Okay, welcome back to another Physical Sciences 3 lecture, and we are now looking at example 9, which is another Newton's second law example. This one is on page 37. Okay, so the mass of a lift and its occupants is 600 kilograms. Calculate the tension at the bottom of the cable supporting the lift when it is moving. Alright, so basically, um, in this example here, we have 600 kilograms. We have the force of gravity as always, and then what they want is just the tension force there, upwards with a uniform velocity. Okay, so I think in this case we'll just go upwards as positive. See how that works out for us. It's going upwards with a uniform velocity. So remember, when uniform velocity means that A equals 0, which implies that F net equals 0. So because F net in our case is equal to Ft minus Fg, and if F net is equal to 0, this implies that Ft equals Fg. Alright, so upwards with a uniform velocity. So then if Ft equals Fg in this case, because it's not accelerating, it's equal to its mass times by gravity, which is equal to 600 times 9.81. And let's have a look. Oops, not my snipping tool, I don't want that one. Gee, clicking on lots of wrong things there. We want 600 times 9.81, and that becomes, we're going to three significant figures again, so 5,890 newtons we'll put in there. And it's upwards. Okay, so that's all going through that cable. Now, with a uniform acceleration of 0.45 meters per second downwards, okay, so this time F net equals 600 times by negative, what did I do before as well? Fg, yeah, that's okay, negative 0.450 meters per second squared. Ooh. Meters per second squared. Okay. So then that is equal to something strange going on. 600 times by negative 0.45 equals negative 270. Okay, so it's going down. And just like before, so F net equals Ft minus Fg. Okay then. So, just a side note here, that if we include the negative in there, then we keep our acceleration due to gravity as positive, because that negative is implied in that. It's already kind of accounted for the negative symbol. So we end up getting 270 is equal to Ft minus the 580 newtons that we worked out before. So we worked out up here that the force of gravity is equal to 5,890 newtons upwards. Okay, so to find the tension force, we need to now add it to both sides. So we get negative 270 plus 5,890. So it gets 5,620. Okay, so Ft will equal 5890 minus 270, which equals 5,000. What did I say it was? 5,620? Yes. Upwards. Okay, 5,620 newtons up. Okay, so this time it's going to be the same acceleration, so which we worked it out here, but it's in the opposite direction. So F net this time is going to be positive 270. So because of that one, so F net equals 270. And I'll just say opposite 2B, part B. Okay, so that's the opposite direction. So F net again, well, same as up here. This time it's positive though, so 270 is equal to Ft minus 5890. So this time we'll add them together. So 5890 plus 270 equals 6160. So F2. Newtons up. Okay. Alright, in part D, can you tell in B or C whether the lift is moving upwards or downwards? Can we tell just from these ones whether it's moving upwards or downwards? We can't, can we? Okay. So all we can say is that it's accelerating. This one was uniform acceleration is coming down. Okay. Uniform acceleration down. But if its initial velocity was upwards, then it would just be coming to rest. It would be slowing down. If its initial velocity was initially downwards, then it would be increasing in speed. Its velocity would be increasing, be going down. Same with in C as well. So we can't actually, because we don't know what the initial velocity was. So we can say, and like, because in our first one we said it was moving upwards with a constant velocity, with a uniform velocity. But this force would have been the same if it was moving downwards with a uniform velocity as well, just because the forces are balanced. This force would have been the same if it was not moving at all. If it was just at rest, this would have been the same force. Okay, so the key thing is, no, we cannot. Tell, as we have no information about its initial velocity. Information about the initial velocity of the lift in these cases. Okay, and that is the end of that example. We'll go on to example 10 next time.